just to kind of give you a broader range of the different types of work that we do. Because there's a lot, I mean, the principles are the same and traffic engineering principles are the same, but they're applied in a lot of different ways. So just kind of a general overview for our department. We review all the traffic and safety elements of projects, so signing, striping, traffic signals, all the interchange work that gets done. We coordinate with the Traffic Operations Center. That includes things like freeway management and incidents and special events. Then we're over the safety components, so that includes crash analysis, and then there's the Highway Safety Improvement Program. So our group is responsible for coming up with ideas for future projects to improve traffic safety within our region. Then we deal with maintenance of traffic during construction, and so that's a lot of the hours contractors are allowed to work and working with them on how they're staging and phasing their construction and how traffic's gonna operate through the work zone. And then we deal with permits as well, so that could be anything from utilities that want to cross or tie into the road to access management and where driveways and how roads and driveways connect to businesses and to the state highway. So just a little bit more knowledge about each of those categories. So interchanges are one of the most complex projects that we work on from a traffic operations perspective. Other than coming up with a concept for a project, one of the first phases in the project is working on an environmental document. And that's where most of a lot of traffic analysis is done. This is just a picture from the SIM model, so that's a traffic modeling software, and so we're looking at various alternatives for which type of interchange design or project design is going to work with the particular volume projections that we have. So they get that information from start out with a travel demand model where they look at land use projections and then come up with more refined turning movement counts and things for the particular project area, and then put it in the model. The other traffic analysis that we do in connecting to the interstate is an interchange access request, because any modification to an interchange or request for a new interchange also has to be approved by the Federal Highway Administration. So we submit our traffic analysis to them and they review those documents. This is an example of a figure from a project that we worked on. It's at 5600 South. It's near the Ogden area next to Hill Air Force Base. And so on the left is what the interchange is currently configured as, and so there's a loop ramp and it's sort of a diamond but not completely, and then it's going to be converted to a single point urban interchange. So I don't know how many of you are familiar with what the different types of interchanges are called in the state. Can anybody think of any names of what those are? I don't know if you've ever heard of any of them in any of your classes or on the news or anything like that. It's test time.
Why do you guys?
Was it different types of interchanges you
Yeah,
said?
different names of different types of interchanges.
There's the Cloverleaf
Okay.
and Diverging Diamond, Spoolie.
Okay, there's a hint there. Diverging Diamond, Spoolie.
All directional, or like four directional.
Yeah. Okay. There's a lot of different types. We do have a lot of different types in the state. This first one here is a diverging diamond. This one was built 3 years ago, It's at I-215 and Redwood Road. And so we used an existing bridge on the left side, and then they built the other bridge to go with it on the right. This next one is a spooey, and this one is built in Layton. And in addition to the spooey, this also has what Utah is called a through turn. It's kind of a modified Michigan U-turn. And so there's a U-turn on the north, west, and south legs, and then kind of off to the east, there's another U-turn. And so we combined those together. Looking at different traffic conditions and the combination of like design constraints that you have to look at. The reason we settled on this option in this area is because here on the left is State Route 126, and it's really close to I-15. It's that way at pretty much every interchange in Davis and Weber County. And so it had created a lot of congestion to have all of these signals in a row. And we had frequently had vehicles blocking intersections and signs up to tell people not to, enter the intersection and don't block the intersection. And so when we were looking at alternatives, we didn't want to take out all of these businesses on the west side, and so they created these U-turns so that you would eliminate the left turn phases at SR 126 and Hillfield Road. That freed up more time for the major directions, and then transferred all of what were left turns at that main intersection to the U-turns at the other locations. This is, I've heard it called a couple of different things, but this is a displaced left turn. And so, I don't have a laser pointer, but.
There's one over here.
Okay.
Is that, so you've heard a lot of things, but displaced left turn is the only one you can say. It can't be what it is.
There we go. Just hitting.
Right there, the little red,
There
hard
we
to
go.
see.
Okay, there we go. So this is 2600 South in North Salt Lake. The majority of the traffic at this interchange is going to go south towards Salt Lake, and then they come north and get off northbound and turn right in the evening. And so this allows more free flow for that left turn movement instead of having to wait at this intersection opposing that traffic. The other interesting part about this interchange is that this is what's called a J-hook. And that's not really preferable because as you're coming off the interstate, you can't really see the traffic signal like you do at most interchanges. And so that's not the preference of the Federal Highway Administration, but right over here are some oil refineries. And so we obviously aren't gonna take out the oil refineries, and the city wanted to maintain the connection to this street at 800 West. And so this is the alternative that we came up with. But what we did to kind of compensate for that is there are flashers on the off-ramp, and so when this signal is red, then those flashers are activated that says that there's to prepare to stop. The other thing we did was put, there are flashing chevrons on the outside of this curve. And then the other thing that we did is the signal coordination at this interchange favors this off-ramp. And so we're trying to move people as they come down the ramp so that they don't have to stop at this signal. And that minimizes the amount of traffic that's queued up here and reduces the likelihood that there's gonna be a crash. And so we try to do things that, compensate for some of those design issues and tailor the design to what the traffic conditions are. particular displaced left turn, this is up by the Air Force Base. There's a large volume of traffic that comes out of the base in the afternoon, and this also allows them to move more freely. This is more of a traditional diamond. I mean, the shape is a little, not quite a tight diamond, but more of a traditional type of intersection. And there are lots of innovative concepts in traffic flow, but that doesn't necessarily mean that that's the right solution for that particular location. And at this location, there used to be a southbound through movement here. So the signal timing engineer, when he was going through and kind of driving this corridor and we were trying to improve the signal timing, he's like, it would be really great if we could eliminate that southbound through exclusive phase. Because traffic would back up to the east, I don't know, 3/4 of a mile to a mile or more in the afternoon. And so they looked and analyzed a lot of different concepts for this project. They looked at a diverging diamond and other options, but it turned out that really the best traffic operations was to leave the interchange basically like it was, and to put this dual left turn lane in and to eliminate that southbound exclusive phase. And so there's a neighborhood to the north off this screen, and so they reroute that traffic to come out at a different location. So just because it's considered an innovative option doesn't always make it the right one for that location. So you just have to look at the particular design constraints that you have. The next thing we do is coordinate with the Traffic Operations Center. You can see that there was a water line break, and so, yeah, that flooded the road. I was working on a project in Bountiful, and we were just putting a traffic signal in, and the contractor hit a water line that they didn't know was there and flooded the off-ramp in the middle of the day. And a common incident is to have a truck rollover on the interstate, and so we work with the Traffic Operations Center on both the response to the incident and the messaging. A couple of examples of recent things that happened up in our area is that on Interstate 84 in Weaver Canyon, we had a truck rollover that dumped a load of hay on the interstate. And so that closed the interstate for an hour and a half. And so we're looking for ways, how can we stage equipment? How can we work with the maintenance sheds to clear those incidents faster and reduce the amount of time that people are stuck in congestion and the likelihood that you have a secondary crash at the back of the queue. Another recent incident was we had a weather event up in that same canyon. Even though the snow had cleared, the particular atmospheric conditions had kind of made this glaze over the interstate, and so people weren't seeing snow or ice, and they were traveling faster through the canyon than they should, and there were quite a few people who slid. And so our responsibility was to come up with both places to put messages and the type of messages to give people some warning of the traffic conditions there. I couldn't come to BYU and not talk about what we do for special events like the BYU football games. And it's not just BYU, it's the U and Utah State and concerts and fireworks, and Utah is really runs a lot of special event plans for a variety of events all year long. And so this particular graph shows that prior to us starting to run those special events, the police controlled the intersections. Well, obviously the police officer can't really communicate with the next officer and the next one down the line to say, okay, we're gonna let all these vehicles go through, like on University Avenue, we're gonna let them go through 5 signals before we stop. And so they started doing these special event plans, they reduced the amount of time for people to get home significantly from what it was before. And Utah has a good central signal system that allows us to run a lot of specialized timing plans at different intersections and to deploy those plans all at the same time. And which, when we acquired that signal system, was more unique than in other places in the country that weren't doing their special event management to that extent. Another special event that we worked on in our area is the Air Force Base Air Show, which draws a lot of traffic from all over. We had one operation for 1 year, but the Air Force Base had the desire to change how the traffic flowed into the base. And so just to show that there are gonna be things that don't go according to plan, and you have to learn from those and adapt to them. The first time we had everyone come through the gate that I showed you on one of the previous interchange slides. We had coordinated with the base about how to park vehicles and how they were gonna move traffic on base, but that didn't work like we planned, and it ended up that traffic backed up onto the ramp and onto I-15, and the highway patrol was trying to route them to not be stuck on the ramp. And there were people who ended up sitting on that ramp for an hour or an hour and a half and never got on base to watch the air show. So we took all those pictures and all that data and went back to the Air Force Base and said, we need to do something different than what we did last time. And so we came up with a better plan for them to park vehicles and to keep traffic moving through the gates so that we avoided the same congestion on the ramp that we had had the time before. So one of the things that Utah has is the ability to collect data from all of the signalized intersections, basically all the signalized intersections in the state. We're one of the few states that has communication to all of our traffic signals to our central system. And we collect a lot of data, basically 24/7. And so we're able to get traffic counts, and this is from the next time that we did the air show event, was 2 years later. And you can see all of the traffic coming in on Saturday morning and how we were able to get all of the traffic through and when that peaked and the demand started to taper off. This was right before, so the Thunderbirds were the big performers that day, and so they performed at this time, and then you can see all the traffic that was coming out right after that event. And so we were able to take that data and look at the performance of our plans and have much better coordination with the Air Force Base and have things run a lot smoother the next time. So the next area that we're responsible for is coming up with safety projects. And one of the so we have a lot more information related to crashes and being able to locate them geographically than we did before. We used to have to pull like the mile point and the intersection from our database, and now it's GIS based, and it allows us to do a lot more analysis than we could do before. And so if you had to guess, what type of crashes do you think are most likely to be severe injury or fatal crashes?
Left turns.
Left turns, okay. Intersections. Any other kind?
I think if one vehicle goes in a T-bone fashion to another one, that's a more direct impact.
Yep. No, absolutely.
Involving pedestrians or?
Yep, there are a fair number of pedestrian crashes. Another another crash type that's likely to result in serious injury or fatality are roadway departures. Intersections and roadway departures are the crash is most likely to result in serious injury or fatality. And so we look at that data and we try to identify projects that we can do to reduce the likelihood that's gonna happen. One of the areas of concern for us are high-speed, rural, two-way stop controlled intersections. For the amount of traffic that goes through those kinds of intersections, so you've got the main route that's like 60 miles an hour and you have stop signs coming in on either side for the minor street. And so for the amount of traffic that goes through that intersection, we've had a number of fatalities at those types of intersections. So we're looking at options of what we can do to reduce the likelihood that those are serious injury or fatal crashes. A couple of things that we're looking at now, this is from the AASHTO Green Book, and is a diagram of a restricted crossing U-turn intersection. So this is the main high-speed route, and then you have a stop sign on either side. Instead of trying to go directly across or make or turn left out of the intersection, you make a right, and then you come and you make a U-turn and come back. And so we don't currently have one of these in the state of Utah. Other states have used this type of design for high-speed rural intersections. And so we're looking for a place where we can try this alternative. One of the big concerns that people have about this is because it is rural, the farm equipment and trying to get their farm equipment from one side of the road to the other. And one of the things we talked to them about is, well, if you have to go all across all these lanes of traffic and traffic's going 60 or 65, you're gonna need to have a long distance to get those vehicles across. But part of their concern is how long the farm equipment has to be in the median. But other states have had similar concerns, and they haven't found that that has been an issue. There are a couple of these systems. This is a rural intersection conflict warning system. And there's a couple of these in southern Utah. But what this does is when a vehicle comes in on the side street, there's a detection, like at a signal, and then it triggers a flashing warning sign on the main route. And so it lets drivers on the high-speed route know when there's a vehicle approaching. So if this vehicle runs the stop sign, hopefully drivers on the main route are alerted by the flashers and will reduce their speed, at least on approaching these intersections. And then, because we've had flashing stop signs at some of these intersections and still haven't seen the results that we would like in reducing serious injury crashes. And then we're adding rumble strips on these side streets as well to draw more attention to for vehicles as they approach the intersection. Another thing that is a popular topic in transportation is pedestrians. And one of the things that we've noticed as we've looked at crash data, as well as some national presentations that I've listened to, is the correlation between shopping and transit and high-density housing. And those pedestrian generators are places where we've noticed that we've had pedestrian crashes. And so this is a location where we installed a pedestrian hybrid beacon. And so we're looking at more strategic places to put those where we see those kinds of conditions together. This is another location where we've had a lot of pedestrian crashes. This is a segment up in Ogden. This is a rescue mission, and there's other homeless services. And so we're installing a pedestrian crossing here, but the other thing that we're doing as a safety project is adding additional street lighting, so that even if pedestrians choose not to use the crossing, hopefully the additional lighting will make the pedestrians more visible to drivers as they go through this section. newer technology that, this is the first time that we've used this in the state of Utah, is, this is a dynamic truck rollover sign. And so, the same canyon that we've had a lot of truck rollover crashes, that we've installed these signs, and they just became active, I think, in September of last year. And what this sign does is it has detection on it, and when a large truck, something that's longer than 20 feet, and is a high-profile vehicle, goes through and they're traveling at greater than 55 miles an hour, which is the posted speed limit for that truck, it will flash on this sign and alternate these messages when it detects a vehicle that meets that criteria. And so, at least in the research that they did, it said that there was a 56% reduction in truck rollover crashes, and so we don't yet have the data to analyze what our, how our canyon responds to that, but anyway, that's a new, newer technology to the state of Utah anyway. So, the U-turn project that I talked to you about before, this is an example of a diagram that we sent out to the public when we did traffic construction and built that interchange. And we knew that it was gonna be a lot different, the traffic pattern during construction was gonna be a lot different than what people were used to. And so, and it was gonna take them longer to get through the interchange because they were gonna have to come off here. Instead of being able to turn left, they were gonna have to turn right and go around that U-turn. And so we tried to prepare people in advance as much as we could of what those traffic impacts are. So that when they knew that they were gonna be sitting in traffic longer, they were expecting it and they could plan and prepare for it. This is some of the plans from the temporary signal operations when that interchange was constructed. This is the work zone that they had at that time. And so that we put protected left turn phasing in because they wouldn't be able to see the opposing direction of traffic very well. And then everyone, like I said, had to turn right off of there. And so you may not be able to avoid traffic impacts during construction, you probably won't, because it's hard for the contractor to get in there and work and still maintain the normal flow of traffic. But being able to prepare people and communicate to them what those impacts are helps them to be more tolerant of when they have to sit in traffic and prepare better. Again, these are some diagrams from the signal performance metrics where we were able to record the data and see what the volumes were when that right turn only detour was in place and compare them to how things are operating after construction. The last area that we cover is permits, and the kind of permits that we get can range anything from this very large development in Farmington to a single family home. And they're all wanting driveways or access to the state route. And this was a very large traffic impact study that was done. I think that the volumes coming out of this access, there's probably about 1,200 right turning vehicles in the peak hour. Which is quite a bit for 2 lanes coming out of there. And so we have to be able to identify what those impacts are and things that we can do to help improve the traffic system in response to those impacts. And so there's really quite a bit of variety that makes this job not boring or the same every day. So we do have a rotational program that if you are interested in any information about that, this is the this is what the web page looks like. You probably can't see this link at the bottom, but I can give you some information or a card. If you would be interested in an internship or the rotational program, we need lots of good people to come work there. So I just wanted to show, hopefully this video works better than show that. Maybe I need to exit out of that screen.
It's extending it over, and we can try and pull it up on this other one.
Okay, here it is. So, this is just a short video that highlights, some of our projects, from 2020.
I don't know if it's gonna, it sounds like it's not giving you sound.
Not sure if there is sound.
Check out this Virgo.
Oh, man.
They're your cousins.
There we go.
I'll skip over here again.
I think we're working on a lot of great projects. And that, that working for UDOT has been a fun and challenging and rewarding, experience and career. And you get to work on something that's meaningful to people and it affects their lives every day. So, anyway, with that, that's all I have prepared. So, do you guys have any questions? Yeah.
Given that Utah's growing so fast, transportation is just like I think it's just gonna become bigger and bigger of an issue, and solutions are gonna be required. Do you feel like working for UDOT, do you feel like there's kind of a shift towards other modes of transportation besides the road and car method, or do you feel like that's still kind of dominant ideology?
I mean, in terms of the number of people that you move with different forms of transportation, there's definitely more people that still drive their cars. But UDOT definitely has had a bigger push to incorporate different types of, different modes of transportation. There's been a much bigger emphasis on building trails, long trails like are adjacent to the Legacy Highway, as well as supporting, bike lanes or trails adjacent to our routes. Our state routes aren't necessarily the most conducive to having, bike lanes or, just because of the speeds. But we are supporting or constructing with some of our projects trails